Okay, so now we're going to do another example. Now, in this example, we're going to do an area. So we want to find the area of this cardioid, right? So again, this is a cardioid. So make sure you understand. So once you have a visual of what kind of shape this is, and you understand the behavior, you'll know how this is going to work. So in this case, a cardioid goes from 0 to what? Well, when does it go to 0? So a cardioid starts at the origin, at the pole, and comes back to the pole. So we're going to set this equal to 0. So in this case, we get cosine theta is equal to 1. So when is cosine theta equal to 1? Easy. Cosine is equal to 1 whenever theta is what? 0, 1. To 2 pi. And then because again, cosine is a periodic function with period 2 pi. So it goes, so one trace of the cardioid goes from 0 to 2 pi. So that's our limits of integration. Okay, great. So now that we got that, now all we have to do is set up our integral. So the area is going to equal 1/2 the integral from 0 to 2 pi of our function, oops, not f of x, okay? But again, what's f of theta? F of theta is 1 minus cosine theta. So let's substitute that in. And so it's going to be 1 minus cosine theta squared d theta. And so now we're just going to simplify this thing. So this is going to equal 1/2 the integral from 0 to 2 pi. And this is going to be 1 minus what? 2 cosine theta plus cosine squared theta d theta. Okay? Okay, so now here we have to remember our identities again. Okay? So in this case here, we have that cosine squared that we have to deal with. Okay? And again, we don't want to use the Pythagorean identity here. Okay? We want to use the other identity that we should be familiar with. Okay? Okay, so make sure you're familiar with the identities. So let's do that. Okay? So this is going to be one of those half-angle identities again that you want to be familiar with. Okay? Oops, wrong one. Okay, so this is going to be equal to 1/2 0 to 2 pi. And so this is going to be 1 minus 2, oops, cosine theta plus, so this is going to turn into 1/2 times 1 plus cosine 2 theta d theta. Okay, so now we've got everything the way we want it, and we can go ahead and simplify. So this is going to become 1/2 the integral from 0 to 2 pi of 1 minus 2 cosine theta plus 1/2 plus 1/2 cosine 2 theta d theta. And so again, we can combine like terms. And so we get 1/2 integral from 0 to 2 pi. And this is going to give us 3/2 minus 2 cosine theta plus 1/2 cosine 2 theta d theta. And so now we're ready to integrate. And so we get equal to 1/2. And we get 3/2 theta. Again here, the antiderivative for cosine is what? Sine. Okay, so this is going to give us minus 2 sine theta. And again here we get plus 1/2 cosine 2 theta. So we're going to divide by the derivative of the inside. So this is going to become a fourth. So it's going to be 1/4 sine 2 theta. And this is going to be evaluated from 0 to 2 pi. Okay, so now sine is easy because guess what? Sine is 0 for all multiples of pi, all integer multiples of pi. So that means at 2 pi and at 0, these are going to be 0. Okay, so what do we get? We get 1/2, and we get 3/2 2 pi minus 0. Okay, and so what do we get for our final answer? We get, well, we multiply here and we get 6/4. Right? So that's going to give us 3 pi over 2. And that's the answer. Have a great day.